Look up at the night sky, at that silver disk that has inspired poets, lovers, and scientists for centuries. We've grown so used to it, we take it for granted, just part of the backdrop. But that's a dangerous mistake. The moon isn't a pretty nightlight. It's a keystone of our existence. No moon, no tides. Our planet would spin much faster, whipping up hurricane-force winds. The tilt of Earth's axis would wobble, and climate would descend into chaos. And without the moon, we probably wouldn't be here at all. The strangest part? By the laws of the cosmos, the moon shouldn't even be here. The universe has rules, especially for rocky, Earth-like planets. One of them is simple. Small, rocky worlds either don't have moons or they only have tiny ones. Earth breaks that rule. The moon is a glaring, almost impossible anomaly. It's less than 4 times smaller in size than Earth. Think about that. This is not a pebble in orbit. It's a gigantic sphere. Yet its mass is only 80 times less than our planet's. No other rocky planet in the solar system has anything like it. It's like a person keeping a pet the size of a gorilla. It just shouldn't be there. To get a sense of how odd this is, look at our neighbors. Mercury and Venus are lonely, scorching worlds, drifting through space with not a single moon. Then there's Mars. It has 2 so-called moons, Phobos and Deimos. Calling them moons feels like an exaggeration. They're captured asteroids, irregular, potato-shaped rocks Mars snagged with its gravity. Now look at Earth. The difference is striking. Our moon is so large compared to Earth that the whole Earth-Moon system upends expectations. Scientists increasingly call it a double planet, much like Pluto and its companion Charon, both orbiting a shared center of mass, as if 2 partners in a cosmic dance. For a long time, scientists searched for a simple, elegant explanation for this anomaly. Could Earth have simply captured a passing moon with its gravity? Calculations show that's practically impossible. Gravity doesn't work like that. An object the size of the moon would either collide with us or be flung away like a stone from a sling. So what if they formed together from the same cloud of dust and gas? That doesn't hold up either. The Apollo missions brought back lunar rocks. Analysis showed the moon's composition differs too much from Earth's. Its iron core is disproportionately small. It's not our twin. And so, we're left with a puzzle. We have an anomalously large moon with a peculiar composition. It stabilizes our planet and makes life possible. And no slow, natural explanation can account for it. That pushes us to a shocking conclusion. If no other body dragged the moon into orbit, if it didn't form alongside Earth, then something staggeringly violent and vast must have happened long ago. What if our moon isn't a gift from the sky, but a scar? A scar from the single most colossal catastrophe Earth has ever endured? The answer came from the moon, literally. When the Apollo astronauts returned home, they didn't bring back just rocks. They brought a key to a mystery. In sterile labs, under microscopes, scientists saw something that made their hearts race. The very first samples of lunar soil looked eerily like material from Earth's mantle. Not from the core, not from the surface, from deep inside our planet. That wasn't a hint. It was a deafening cry from the past, a story not of birth, but of violent creation. This is how the most elegant, and at the same time, most terrifying theory in planetary science was born, the giant impact theory. It proposes that 4.5 billion years ago, the young solar system was a restless, chaotic place. And wandering through it was another world. Scientists gave that stray planet a beautiful name, Theia. In Greek myth, Theia was a titaness, the mother of Selene, the goddess of the moon. The name fit perfectly. This wandering world was about the size of modern Mars. It had roughly 1/10 the mass of proto-Earth, more than enough to unleash a catastrophe on a cosmic scale. Theia wasn't just an asteroid. It was a full-fledged world with its own core and mantle, and a fate already sealed. Their paths crossed. We watched Theia closing in on a young, still molten Earth. This wasn't a head-on smash that would have destroyed both worlds. No. It struck at a precise, glancing angle, like a colossal cosmic projectile scalping the planet. Theia slammed into Earth on that angle, plunging deep and ripping trillions of tons from the mantle, while leaving the dense iron core largely intact. Earth swallowed most of Theia, folding it into itself forever. But the impact's colossal energy did something extraordinary. Earth, hurled a vast cloud of vaporized rock and glowing debris into near-Earth orbit. It contained billions of tons of material, mostly from Earth's mantle and the remnants of Theia. For a brief, by cosmic standards, moment, our planet wore a ring. Picture a young Earth wrapped in a blinding disk of fragments shining brighter than any sun, like a temporary Saturn. But that ring proved unstable. Gravity began its slow, relentless work. Pieces collided, stuck together, and grew. Over thousands of years, that searing swarm of material coalesced into a single sphere. Ash and fire forged our moon. It rose from ash and flame, mere steps from the planet that spawned it. And then everything clicked into place. It was a triumphant revelation. The mystery of the moon's tiny iron core? Click. It stayed behind on Earth. The impact barely touched it. The similarity between lunar soil and Earth's mantle? Click. The mantle itself had been flung into orbit. The moon's unusually large size? Click. It wasn't a captured asteroid. It was a fragment of the planet. Supercomputer simulations confirmed it. Yes, a grazing impact like that could produce a system exactly like ours. Every detail, every oddity that had plagued astronomers for decades finally had a single explanation: one cataclysmic collision. The giant impact theory was so elegant, so all-encompassing, it became canon. It explained everything. It felt like we'd solved our nearest celestial neighbor's greatest mystery for good, an elegant, mathematically backed solution worthy of the titans who lent it their name. Scientists celebrated. But, in science, tidy answers often hide deeper questions. Amid that triumphant chorus of data, one quiet, discordant note stood out. A single chemical fingerprint didn't match. If the moon formed from a blend of Earth and Theia, then why does its chemical makeup line up with Earth's almost perfectly, as if Theia never existed? Every world in the solar system carries its own chemical passport. That passport lives in its isotopes, the tiny signatures written into atoms. Oxygen matters most here. It comes in 3 stable forms: oxygen-16, oxygen-17, and oxygen-18. The ratio between those isotopes works like a fingerprint, unique to any body formed in its patch of space. The logic was simple and strong. If the moon is the child of 2 parents, Earth and Theia, its makeup should be a mix. Its chemical passport should reveal a blended heritage. Scientists collected samples from the Apollo missions and ran this cosmic DNA test, expecting to find a hybrid. And then the elegant theory collapsed. The results were not just unexpected, they were impossible. Scientists found the oxygen isotopes on the moon and on Earth were indistinguishable, not similar, not close, identical down to the last significant figure. It was as if someone had scooped lunar soil, not from another world, but straight out of Earth's mantle. It landed like a scientific knockout. The most elegant, all-encompassing theory, the one that seemed to explain everything, ran into a single fact it couldn't explain. The whole neat picture of a giant impact backed by supercomputer simulations cracked at the seams. A paradox emerged: the lost parent. Calculations said up to 40% of the moon's material should have come from Theia, an alien body from another part of the solar system. But scientists found none, not a trace, not a single atom declaring, "I'm not from Earth." The moon looked like a direct child of our planet, as if Theia had never existed. That contradicted the theory's core. What had been an elegant solution turned into an unsolvable puzzle, an identity crisis that pushed astrophysicists back to the very beginning. Science doesn't give up. It adapts. Out of the ashes of the old idea rose a stranger hypothesis. What if Theia wasn't really a planet? What if it wasn't a world of rock and silicates at all, but a dense iron-nickel projectile roughly 1,000 kilometers across? Picture a molten ball of metal. It doesn't just skim past, it punches through Earth's mantle like a bullet through an apple. Its ultra-dense core drives deep and merges with our planet's core. The impact throws a plume of pure 100% Earth material into orbit. This model solves the isotopic problem. The moon, in fact, would be almost entirely made of Earth. This is where a tale of cosmic catastrophe becomes a story of creation. The impact was so intense it melted the planet's surface, turning Earth into a sterilized, molten globe. Yet that same blow could also have been its greatest gift. The space projectile that struck our world may have delivered carbon, nitrogen, and sulfur deep into the planet, volatile elements we call the building blocks of life. The cataclysm that birthed the moon could have simultaneously seeded Earth with everything needed for life to arise. A deadly strike became an act of creation. This new picture solves one mystery, but creates another, even more fundamental one. The energy unleashed by such a collision is unimaginable. The heat should have literally boiled away every volatile compound on the young Earth's surface. All the water, every gram, turned into superheated steam and scattered into space. We see a world that survived hellish fire, that received the seeds of life, and yet lost its most essential ingredient. If the impact that gave us the moon should have stripped Earth of its water for good, where did our oceans come from? For decades, the moon stood for absolute dryness, a rocky desert scorched by the solar wind and frozen in a vacuum. In the scientific community, that became almost an axiom. Our satellite was a world without a single drop of moisture. Any water that might have existed at its fiery birth would have evaporated without a trace in the first moments. Every sample the Apollo missions brought back seemed to confirm it. Dry, lifeless rocks. The picture felt clear and final. The moon had been born in fire and remained sterile. Then scientists looked deeper, not at the rock's surfaces, but into their crystal lattices. In volcanic glass and olivine crystals pulled up from the moon's interior, they found something extraordinary: molecules of water. These weren't just traces of comet ice on the surface. Minerals trapped that water when they formed billions of years ago, like a cosmic time capsule. Analysis showed the moon's mantle may hold as much water as Earth's mantle. That lifeless gray ball turned out to be wet inside. And this is where the tidy picture falls apart. Consider two competing ideas. On one hand, a single, giant, searing impact, hot enough to melt rock and to form a fiery disk around the Earth with temperatures in the thousands of degrees. The energy from that blow would have vaporized not just water, but every volatile element, turning them into gas and scattering them into space. On the other hand, an undeniable fact. Water survived the catastrophe, hidden deep inside the moon. That's physically impossible. It breaks the whole logic. That water shouldn't exist, and yet it does. This contradiction opened the door to a radically different scenario, an alternative theory from astrophysicist Nikolai Gorkovy. What if it wasn't one titanic strike? What if there were hundreds? What if the moon didn't form in a single instant, but assembled piece by piece during a prolonged cosmic bombardment? Instead of a single giant object, imagine a swarm of hundreds of smaller bodies, each slamming into Earth one after another. Each impact would be far less catastrophic. None would unleash the planet-wide inferno needed to sterilize the system. Rather than one all-consuming blaze, you'd get a series of gentler collisions that lofted material into orbit, while allowing volatile elements, including water, to survive. Now we stand at a fork in the story of our origins. Two very different scenarios branch out from here. On one side, an elegant catastrophe, a single, colossal impact that neatly accounts for the moon's mass and composition. It fits the lunar facts, but it leaves us with a stubborn water paradox. On the other side, a chaotic, drawn-out bombardment. Many smaller, cooler strikes that could explain how Earth kept its water. It answers one problem and complicates everything else. So, what actually forged our world? A single, fiery act of creation that brought the seeds of life but should have boiled away the water, or a series of milder impacts that preserved it? And where does the final answer live? In sweeping supercomputer simulations, or in the oldest rocks locked inside the Earth itself? The answer isn't in computers. It's not in Earth's rocks either. It's waiting up there, in the cold silence of the moon's caves. This isn't made up. These are real geological formations, giant tunnels carved by lava flows billions of years ago. Sunlight has never reached them. Thick layers of rock shield these spaces from cosmic radiation and meteoritic dust. They are the last untouched frontier in the solar system. And there, in eternal darkness and absolute cold, lies the key to our origins. The eternal darkness of these caves isn't empty. It's a perfect vault, a cosmic archive holding material flung off Earth during the catastrophe, kept in its original state. On the moon's surface, the solar wind has long mixed and altered everything. But deep in those caverns, the original stuff may still sit, and it could give us the final answer. One fiery strike, or hundreds of cooler impacts, and there, in endless shadow, ancient ice might be hiding, the very water that by all accounts shouldn't have survived the cataclysm, yet did. Studying that ice could tell us how. By unraveling the moon's mystery, we discover something far larger. Impact events do more than destroy. They act as a universal cosmic engine of creation. Every asteroid strike is a giant chemical reactor. It melts rock, releases water, and creates the unique conditions needed to synthesize complex molecules. Crack the moon's origin, and you unlock a universal recipe. The moon isn't just an example, it's a Rosetta Stone, a key that lets us read the story of life's beginnings anywhere. This isn't just a theory. Evidence quite literally falls from the sky. In meteorites that still plunge through Earth's atmosphere, scientists find amino acids, the same building blocks that make proteins. Those are protomolecules of life drifting through space. They already existed in the cloud of dust that gave rise to the solar system, and the massive impacts that formed the moon did more than smash rocks together. They delivered vast amounts of raw material to a young, sterile Earth. Impact, water, organics. That's a universal recipe. If it worked here, it could work on other worlds too. We look at Mars and see dried riverbeds. But what if impacts buried organics beneath the surface, shielding them from radiation? And life still clings on down there? We look at Mercury, a blistering world. Yet even there, in deep polar craters, permanent shadow hides water ice. Impacts might have carried organics into those cold pockets. Life could be hiding in the most unexpected corners if this violent, fertile process created the conditions for it to begin. All of this, from a giant impact to amino acids tucked inside meteorites, changes everything. The next time you look up at the night sky, don't see just a cold, dead rock. See a monument, the greatest monument to a catastrophe that didn't destroy us. It gave us a chance. The moon is a scar on the face of the cosmos. Every day it reminds us that sometimes for life to be born, an entire world must first die.